Okay, to finish up this section, we're going to look at the trigonometry of real numbers. On the unit circle, when the radius equals 1, the arc that's created by the intersection of the circle and the angle are the same in measure. I should put this as R. The same in measure. Now, let me just show you that real quick here. Here we are again. Notice this arc here. This is in yellow, so it's a little difficult to see, but nevertheless, you'll notice the number 0.96, the length of this arc here, also happens to be your angle measure in radians. Okay, and if I move this around, you can see here we're at 2.14 radians. The arc length is also 2.14. This is a result of having a circle with radius 1. So we're going to use that property to look at any function of the angle theta as a function of the arc length. Okay, we'll call this t. Now, t can represent the arc length or the angle of rotation. Alright, this kind of comes back at setting you up for understanding trig functions as a function of the angle or the arc length here. Alright, so we want to evaluate the 6 trig functions for t equals 3 pi over 2. Well, first thing we need to understand is 3 pi over 2 is an angle that falls right here. 3 pi over 2 is also 270 degrees. The point on its terminal side on the unit circle is 0, -1. Okay, so if we go back to our definitions here, pretty simple. Sine equals y, so it's -1. Cosine equals x, which is 0 at 3 pi over 2. Tangent's kind of an interesting one here at 3 pi over 2. It's equal to y over x, which notice is -1 over 0, which is an undefined amount. Okay, we'll need to look at that here in a second. We have -1 is cosecant because it is the reciprocal of sine. Secant would then be the reciprocal of cosine, which is 1 over 0, so it is also undefined. And cotangent is 0 over -1, which is the reciprocal of tangent, and that equals 0. Okay, now, what we haven't run into yet is really this right here, which leads us to believe that some of these trig functions have a restricted domain. So let's take a look at that really quickly here. The domains of the trig functions. Alright, the question here is, if I put in an angle, what can I get out? Well, remember, sine of the angle is just equal to y on the unit circle. And for any angle I put in, I'll get a y value out. So really, I can put any angle in sine. It doesn't have any restrictions. Cosine is similar. I can put in any angle and get some x value out. Okay. Tangent, on the other hand, which we just saw, since it's y over x, and x cannot equal 0, that's going to occur anytime t is equal to pi over 2 or some multiple of pi added to that. By the way, we're going to put a little note here that n in these problems is an element of the integers. Okay, in other words, 1, 2, 3, 4, 5, 6, 7, -2, -7, -30 is n. And all that's saying is, if you notice here, like in our last example, our x value was 0. If I added pi over 2 to it, okay, I would have 0, 1. And notice that will cause me to have a 0 in my denominator of tangent. So tangent's domain is restricted. You can put any number in except t cannot equal pi over 2 or any multiple of pi. Cosecant, which is 1 over y, we have to remember y cannot equal 0. Now that's going to happen on the right and left of the unit circle at 0 and pi. So it's going to be all real numbers except t cannot equal any integer multiple of pi. Hopefully you'll explore these a little bit more in your class. I'm not really going to do it a ton of justice here, but just realize that these trig functions that have variables in their denominator are going to have restrictions on their domains. Now secant, since it has an x in the denominator, just like tangent, okay, it's going to be restricted in the same places. So it's going to be restricted at any pi over 2 plus n times pi. And lastly here, cotangent, which is x over y, it's going to be restricted wherever cosecant is restricted, because y cannot equal 0. So again, it's all real numbers except t cannot equal any integer multiple of pi. And that's it.